Welcome to the wonderful world of astronomy. We are in Chapter 7, studying our solar system. And in this fifth video, we're going to look at missions to other worlds. In this video, I'm going to talk about 4 different types of space missions. And here is the summary, the bottom line up front, and I'm going to talk about each of these types. The first type is a flyby, which flies by another world once, and then it keeps on going. The second type is an orbiter, which goes into orbit around the other world. The third type is a probe or lander, which either lands on the surface, or in the case of a world where there is no surface, like a gas planet, it'll just go into the planet. And the fourth type is a sample return mission that goes to another world and returns a sample of another world's surface to the Earth. Let's look at the first type, flybys. A flyby mission flies by a planet just once. The benefit of it is that it is cheaper than the other types of missions. However, the downside is there's less time to gather data. Now, a good example is the Voyager 2 spacecraft. Here you can see its trajectory. It launched from Earth in August of 1977. Its mission was to do close studies of Jupiter, Saturn, Uranus, and Neptune. And so it launched from Earth and it made its way to Jupiter. And you can see about 2 years later, it got to Jupiter. Once it was flying by Jupiter, gathering as much data and information as it could, it used Jupiter's gravity to swing around and go towards Saturn. Now, you've learned that the planets are all in motion, they're all in orbit around the sun, so they had to aim not at where Saturn was at the time, but where Saturn was going to be in August 1981. And then they had to aim, once it got to Saturn, had to aim not at where Uranus was at that moment, but had to aim at where Uranus was going to be when it got there in 1986. So you can see the path that it took. It went past Saturn in 81, went past Uranus in 86, and finally it completed its mission passing by Neptune in 1989. So a 12-year mission. The Voyager 2 spacecraft continued going, sending information back to Earth, and it continues going on to this day. Here's Voyager 2 by the numbers. You notice it says Voyager 2 Interstellar. That might be a bit of an embellishment, but the fact that it's left our planetary system, and the idea is that now it is going on to other stars. At the speed it's going, it would take about 40,000 years to get to the next closest star, but it's not even heading in that right direction. But it is going out into interstellar space now. Here it says this slide was made in 2018. It says here at the bottom. So as of the making of the slide, it had been in space for 41 years. Miles per hour relative to the sun, 34,000 miles per hour. It gave us much close-up information along the way. So here you can see Jupiter, Saturn, Uranus, and Neptune, pictures that it took. And these were the first up-close pictures up until the time when Voyager got to Uranus and Neptune, especially those planets. We didn't really have any good pictures. We just saw them as lights in the sky, but here we're able to see for the first time how beautiful they are. The next type of mission is an orbiter. This spacecraft goes into orbit around another world. Now keep in mind, all these spacecraft, most of the spacecraft missions that I'm talking about in this video are unmanned. They are robotic spacecraft. There have been a few manned missions, notably the Apollo missions that went to the moon. but all the other ones are unmanned. It's just a lot cheaper and easier to send robotic spacecraft than actually have to support support astronauts with water, food, and all their needs. An orbital spacecraft, it goes into orbit around another world. The benefit of that is there is more time to gather data as it just stays around the world. However, it cannot obtain detailed information about the world's surface. And I'm using the general word world, because we could be talking about another planet, we could be talking about a moon, we could be talking about an asteroid, anything out there that we're exploring. So in this video, I'm just generally using the term world to be the object of what we're exploring. Now, an orbiter is going to be more expensive than a flyby, because with a flyby, you need enough fuel to break free of Earth's gravity, but then using Newton's first law, you just go towards the object that you're going to study, the world, and you just keep flying. And Newton's first law takes care of, it just makes it go in that direction once you point it in that direction. An orbiter is going to take more fuel, because not only do you have to break the spacecraft free from Earth's orbit to launch it, but then you have to slow it down, so you need more fuel to do this, and put it into orbit around the new world. So that takes more fuel. And by the way, the more fuel that takes to put into orbit, that means that there was more weight on the spacecraft, which means you needed even more fuel to break it free of Earth's gravity. Here's a good example of an orbiter, the Cassini space mission. The Cassini was a spacecraft that was put into orbit around Saturn. It was a joint effort by NASA, the European Space Administration, and the Italian Space Administration. It also carried with it a probe, and later in this video I'll talk about probes, the Huygens probe that went to the moon Titan. Cassini orbited Saturn from 2004 to 2017, and it studied Saturn. It got a lot of good information about Saturn, about its composition, its gravity, its magnetic fields, lots of information, lots of good pictures. And it studied many of Saturn's moons and Saturn's rings. Here you can see pictures of it. There it is on the launch pad on the left, and on the right is the actual Cassini spacecraft that would go into orbit. And here you can see size comparison with some people. There's a animation of it. And here are many moons of Saturn that it studied, took pictures of. And this one down at the left with all its craters, and one big crater in particular looks kind of like the Death Star from Star Wars. You can see the larger moons are more round in shape, and then there's a lot of smaller moons. Some of these moons might only be 40 or 50 miles across. The Cassini mission lasted much longer than they originally intended. So it just kept on orbiting. It was in orbit around Saturn for all those years, so we learned a lot. But then finally, its mission was over. There was nothing more to do with Cassini. So its final grand finale was that they plunged it into Saturn. And on the way into Saturn, taking as much information as possible, and then being destroyed by the high pressure. So the Cassini orbiter, on its final steps, became a probe. And that brings us to our third type of space missions, probes or landers. A lander will land on another world. If there's a solid structure to land on, a surface, then it'll land on it. A probe will plunge into the world. Maybe it's a gas giant, maybe it's the sun. It'll go into it and not be able to land. The benefit is it can explore the world in much greater detail than an orbiter or a flyby could. The downside is it is more expensive. It's harder to engineer. There's more fuel also. And so you think it needs enough fuel to break free of Earth's gravity. It needs then enough fuel to go into orbit around the world. And then it needs enough fuel to make a safe landing, if it's a lander, to make a safe landing down onto the surface. All this requires much more fuel and some tighter engineering. Here you can see some pictures. This one, actually a painting of a Mars rover, and this one is of a spacecraft. Perhaps it's the, I don't even know what this picture is of. I think it's the Huygens probe that went from the Cassini spacecraft and landed on Titan. An early example of a lander is the Viking 1 and Viking 2 landers. They landed on Mars in 1977, and these were some of the first pictures that we got up close of the Martian surface. This is an animation of a Mars rover, the Curiosity rover. Earlier, I talked about the Cassini spacecraft that was in orbit around Saturn. Part of it was the Huygens lander. So this is a spacecraft that separated from Cassini on Christmas of 2004, and about a week or two later, it landed on Titan, Saturn's largest moon. So it landed by parachute on Titan. It was the first landing ever accomplished in the outer solar system. So prior to that, we had landed on the moon and on Mars, but this is the first one in the outer solar system. And it's the first landing on a moon other than Earth's moon. And in the lower left, you can see a picture of Titan. And here we have pictures from the surface of Titan. Probes are in the same category as landers, but these are things that go to worlds where you can't land. So as you can see up here, don't tread on me, places where you can't land on, but you can still go into them. So for example, sending a probe into Saturn, which is what the Cassini orbiter became in its grand finale, sending probes into Jupiter, even sending probes into the outer atmospheres of the sun. And the final type is a sample return mission. This is a mission that lands on the surface of another world, gathers samples, and the spacecraft is designed to blast off of the other world and return to Earth. The Apollo missions to the moon are an example, and these were actually manned missions in the 60s and early 70s where astronauts went to the moon, landed, they were able to walk around on the moon, they gathered lunar material and were able to bring it back to Earth. There have also been robotic missions to the moon that gathered samples and then took off. The Hayabusa mission actually went to an asteroid, and here you can see a depiction of it landing on the asteroid, gathering data, and then it returned to Earth with some of the asteroid material. And in this small picture here, that is a picture of a lunar rock. Now, there is much benefit to sample return missions. It allows us to take material from the other world, whether it's a moon, an asteroid, someday a planet, and we can analyze it on Earth. And we just have better facilities to analyze it here on Earth. And the downside is it takes much tighter engineering. It's a lot more expensive because you need the fuel to break free first of Earth's gravity, to go into an orbit, to land on the world, and then you need to launch back from the world, breaking free of its gravity, and then landing safely on Earth. so it's a tremendous amount of fuel. Our summary for this video: how do robotic spacecraft work? Just remember there are four main types. The flyby flies by another world only once. An orbiter goes into orbit around another world. A probe or lander lands on the surface. And a sample return mission returns a sample of another world's surface to Earth for study. And that concludes our video on missions to other worlds. Have a great day.